For electricity to flow, we need charge carriers, electrons, or holes to move. Pure silicon looks perfect, a clean, orderly crystal structure, but it's actually not very useful for electronics because there are almost no free electrons moving in the structure. Most of the electrons are tightly bound to their atoms in stable covalent bonds. In its pure form, silicon has very few free electrons to carry current. That means even if we apply a voltage, only a very small current can flow due to the limited number of charge carriers. To fix this, we introduce a small but powerful change. We add tiny amounts of impurities into the silicon crystal, a process known as doping. These impurity atoms replace some silicon atoms in the lattice, slightly disturbing the balance and creating charge carriers. If we add atoms like phosphorus, which have 5 valence electrons instead of 4, they form bonds with the surrounding silicon atoms. But 1 electron is left over. This extra electron is not tightly bound, so it becomes free to move through the material. As more of these atoms are added, the number of free electrons increases, allowing current to flow easily. This creates N-type material, where negatively charged carriers of current. But if we instead add atoms like boron, which have only 3 valence electrons, something different happens. When boron bonds with silicon, one bond is incomplete, leaving a gap where an electron is missing. This gap is called a hole. Nearby electrons can jump to fill this hole, leaving behind another hole, making it appear as if the hole itself is moving through the material. This is P-type material, where positively charged holes carry current. By carefully controlling how many impurities we add and what type we use, we can precisely control the electrical behavior of silicon, turning it from a poor conductor into a useful material for electronics. And when we bring N-type and P-type materials together, we create a PN junction, the fundamental building block behind diodes, transistors, and almost every modern electronic device.